Okay, good morning, everyone. Sorry for the 2 minutes delay. Questions about anything. The day before your exam is usually for you guys. I don't start anything new. So please put up your questions on chat and I'll answer every questions you have. Hi, Professor Elias. Hi, Rocco. Questions? 5C and 6. Okay, 27, please. Number 16. Okay, all right. Okay, let me write them down so I keep track with them. Okay, so 5C and 6. Rocco, and then 15, 19, and 27. I assume those are all from the review, right? Number 16 on the review, and 27 on 6-1. Okay, all right. And 3Q. Okay. We will do everything. All right, so I'm gonna do those. 27 is from the homework due today. Yeah, I got it. I got that there. Yeah. And could you cover, uh, will we get a sheet with some of the I will talk about that, the classroom, yes. And would you also cover number 18? Okay. I will try to cover everything you guys asked in order, all right? As far as formulas, what I will give you for sure, what I will give you is arc length and surface area. Those I will give you. What I don't give you is, of course, volume of a disk, which is pi times r squared times times the height, and I will not give you the volume of a washer and a cylindrical shell. So I will give you arc length, surface area. Those you do not memorize at all. You are responsible for volume of a disk, of a washer, and of a shell. So, and that's the only thing you're responsible for. I don't think it's a lot, right? Okay. So I will start with your question. I try to go by order of the numbers. So 3Q. Okay. So number 3, part Q, I will do that first. The number 3, part Q. Okay, so we have the following question. Find the integral of x times 2x plus 1 to the power 3 dx. And u equal 2x plus 1. Oh, that's okay. 3j. Very good. All right, so let's do that. Du, the derivative here is 2 dx. And as I said several times, this is the type of problem I usually will tell you the u. Your job is to substitute correctly. And it's going to become equal to 2x plus 1 is the u to the power 3. And the dx is half of the du. But I still have to deal with the x because the derivative is not x. So as we said before, the only way you can deal with it is that you have to express everything in terms of u. Express in terms of u. All in terms of u. I don't want to see x at all once you do the substitution. So this would give me, I solve for x, I will get x equal u minus 1 divided by 2. All right, so this x is u minus 1 divided by 2. And now I have to integrate this. A half, those are constant. I can And here I will have, I can get them out. So finally, this is equal to 1 over 4. I distribute du, and this would give me 1 over 4, 1 over 5, u to the 5, minus 1 over 4, u to the 4, plus c. Okay, so finally I will get 1 over 4 times 1 over 5 to x plus 1 to the power 5 minus 1 over 4 to x plus 1 to the power 4 plus c. End of the problem. Any questions about that? Okay. All right, now I'll finish. I do a 3J, so I can finish with number 3. And okay, integral from 0 to 1 of the derivative of x e to the x squared. Okay, so what is the definite integral of that? All right, so I'll open my parentheses here. And I ask the following question. What's the integral from a to b of f prime of x dx? So if I use the fundamental theorem of calculus, what does it tell me? Tell me is the antiderivative. But what's the antiderivative of the derivative? What's the function whose derivative is f prime? Is f itself. So that's the antiderivative evaluated between a and b. It means that's f of b minus f of a. So if you have the derivative as your integrand, so you just get f of b minus f of a. And that's exactly the same problem. What's the function whose derivative is the derivative of that? That's e to the x squared evaluated between 0 and 1. That's important here. Very important. So this will give me at the upper limit 1 e minus at the lower limit 0. This is equal to e. Okay, so definite integral of f prime is nothing more than f at the upper limit minus f at the lower limit. Okay, now 5C and problem 5C. Let's see what this is about. And 6. 6 is, okay. So now I move on to 5C. Part C. So I have the following, the region bounded by y equal x squared and x equal 8 minus y squared. And the question is, find the area. I did not tell you if I want respect to the x or the y, so you do whatever you want. Okay, so first is graphing. Okay, y equal x squared, and when I graph, I need a pencil. That's y equal x squared. X equal 8 minus y squared. So if you want to draw this, just remember how would you draw y equal 8 minus x squared? It's the same principle. It's minus x squared, and then you shift it up by 8 unit. 8 minus y squared is going to be the same, but so it's minus y squared, and you move it up here. So it's going to be like this. And that's 8. Okay, if y is 0, x equal to 8. Okay, so that's really the region in question. So the region we're interested in is this one. Are you with me? Okay, so what do we need? we ask ourselves, do you want me to take vertical slices, horizontal slices? I don't know. What do you want me to do? Vertical, vertical, absolutely better. Because horizontal, I'm stuck in horizontal. I really don't know what to do. Not, I'm not stuck. We can finish it, but I will have really to cut into pieces because the left limit, the left curve, we know it. The right curve is changing. So I really have problem with those kind of slices. So I definitely have to take the vertical slices. Okay, take the vertical slices. And then in this case, this is y equal x squared. No, sorry. This is y equal x squared. And this is x equal 8 minus y squared. If I'm taking vertical slices, it means x is my variable. X is the variable. So I need the height. What is the height? The upper value minus the lower value. Now, what's the upper value? Here I gave you x as function of y. To find the upper value, you have to solve for y as a function of x. So this will give me that y squared is 8 minus x. It means y is the square root of 8 minus x. Okay. Yeah. We take the positive root because y is positive. So the height is going to be the upper value, which is the square root of 8 minus x, minus the lower value, which is x squared. So the height or the length. And then the width is the delta x. Okay. So now the question is, I cannot move forward unless I find the intersection point. What are the intersection points? To find the intersection point, you can either set the axis equal or you set the y's equal, whichever you are more comfortable with. So in this case, do you want to set the y's equal or the axis equal, or it doesn't really matter? What do you want to do? How can you find the intersection point?
Set the y's equal.
Okay, set the y's equal. So it's going to set x squared equal. The y is the square root of 8 minus x. Okay, so this will give me x to the 4 equal 8 minus x. X4 plus x minus 8 equal to 0. Something is bugging me. Do you think this is easier or setting the x is easier?
No.
If I set the x is easier, I will get the square root of x equal, the square root of y equal 8 minus y squared. No, it's the same thing. So what are the solutions?
Quadratic formula.
No, you cannot use a quadratic formula. Why you cannot use it? That's not
Because it's not in the x squared plus
right,
b squared.
right. What's going to be the solution? Unless I meant in the first quadrant, whatever. Can anybody figure out the solution? Something is bothering me. It shouldn't be hard. My mind is going blank for a second. Sorry. I said the y is equal, I will have y equal x squared and y equal, because here I have to guess a solution unless I'm goofing and I'm not seeing my mistake anywhere. Set y equal, I put
Or
in,
should we?
okay, I put in the calculator, yeah, but I gave you the solution and unless my mind is going totally blank for a reason. Hmm. Something is off, I don't like it. All right, keep them interrogation mark. I don't want to spend the time on it. I don't know why my mind is going totally blank for a minute.
Professor Elias, on the answer sheet, you wrote a as with respect to y, and the answer was from -4 to 0 of -y minus the parentheses y squared plus 3y parentheses and then dy. So you used it in respect to y because we know that it intersects between 0 and 8, maybe? I don't know. But that's what you wrote on the review sheet.
All right. I don't know where my mind is going blank for a second. Just let it go and I will come back to it. Okay, I don't want to spend my time on it. I don't know why I'm blanking totally. Unless I'm doing
That's okay.
something utterly stupid.
That's okay, Professor Elias. It's okay.
Okay, I'll come back to it. My mind is totally blanking right now. I don't want to waste time on it. But this should be easy because I've done this a million times. I don't know why it's going happening. Okay, so I will go to number 6. My apology for that. It shouldn't be that. Number 6. Okay, so we have the following graph. And this is y equal 3x squared minus 3. Okay, so that's a typical parabola. So this is a minus 3 in here. And this point right here is a 2. And this has to be 1. Because if you set this equal to 0, you get x equal to 1. And I'm interested in the area of this region right there. Okay, so my question is find the area of the following region. So what are we supposed to do? Question. Is the area equal to the integral from 0 to 2 of 3x squared minus 3 dx?
No,
Yes or no? Quickly.
no.
Absolutely no. So how are you going to find the area?
Set of two integrals and then add them.
Exactly. We have to set it up. From here to here, one integral, and from here to here. Okay, because if we think, 2 reasons, the integral from 0 to 1 is actually minus this area. So you have to multiply this by 1. Another way you can think about it, if you can take this little slice, so if x is between 0 and 1, the upper curve is 0, and the lower curve is 3x squared minus 3. However, if I am between 1 and 2, the upper curve is 3x squared minus 3, and the lower curve is going to be equal to 0. So the area is going to be, we have absolutely to split from 0 to 1 plus from 1 to 2. From 0 to 1, it's going to be, if you want, 0 minus 3x squared minus 3. And from 1 to 2, it's going to be 3x squared minus 3, just the regular area dx. And the rest is simple for you to evaluate. Okay, so the reason I assigned this to be careful that from 0 to 1, first, it's not the integral. You have to split from here to here. It's minus that integral. Another way to think about it, the upper curve is 0. The lower curve is 3x squared minus 1. So that's the upper minus the lower. Okay.
So
And
now
yes,
I have a question.
sure.
So now we're not worrying about negative area. So even if it's below the x-axis, we're counting that as like a positive area number.
Because you're multiplying by minus. You're not taking the integral from 0 to 1.
Right. Yep.
Right. This will be negative, the area. What I'm
Yes.
taking is minus it. You're going to have the positive area.
Okay. That makes sense. Okay.
Make sense? If you take the integral without this, you're going to get a negative answer. You're not going to pick up the area. You pick minus that area. So when you multiply it by minus, you're cutting the positive area. That's one way to think about it.
So for the test, we don't have to worry about negative area like at all, like difference of areas,
It
or
depends on the
do
question. Like the second question that I've assigned. Oh. If let us say my question is something like that. I gave you this picture. Okay, and I just made up number. I'm gonna make like 1, and I'm just gonna make up number here, 3, 4. Okay, and that's I give you minus 1. And that's the function. I tell you, evaluate the integral from 0 to 1 of f of x dx. I didn't ask you to find the area. I only asked you to find the integral. Are you with me?
yes.
And then that's gonna be minus the area. I did ask you about the area. I'd ask you about the integral. The integral is the net area, as your classmate is saying. So if I only ask you about the integral, that's minus the area. That's what the integral means.
Okay, that makes sense. That makes
If
sense,
I
bro.
find
So
it, what's
thank
the
you.
area? That's the area. It's the regular old area that you guys have seen. Okay? Understand the difference?
Yes, I understand now. Thank you,
Everybody
Professor.
else. Yeah. Okay. So I'll just take care of number 6. And I have 8A. Number 8. And it's part A. Okay. And here I have the region bounded by, so R is the region bounded by y equal x cubed, and the line x equal to 1, and the x-axis. So this is my region, y equal x cubed, and x equal to 1. And the x-axis. So that's the region I'm interested in. And part A, we're gonna rotate about the x-axis. So that's part A, that's your question. And I wanted you to do it in this problem. First, this quasher. And B, shell methods. Okay. Now, this quasher, remember here the slices are perpendicular to the axis of rotation. So this is my interval 0, 1. This is my axis of rotation. It means I'm taking this piece right here. This is my xi. And I'm rotating it in my mind. Of course, when you rotate this, you're going to get a disk. There is no washer here because we're touching the axis of rotation. So the radius here of the disk is the value of the function right there. So a typical disk, I need the radius, which is xi cubed, and I need the height of the disk, which is the delta x, and then the volume of a typical disk is pi times the radius square delta x. So the total volume will be the integral from 0 to 1 of pi times x cubed squared dx. It means integral from 0 to 1 x6 dx. End of the problem. Okay. So that's this question. Now the shell method. So for the shell method, it means your slices are parallel to the axis of rotation. So before I do the shell method, I'm going to draw all over again. That's one. This is my axis of rotation. These are my shell pieces. So this time I have horizontal pieces. Immediately you ask, what's your variable? Y is the variable. Okay. If this is 1, this is also 1 because this is y equal x cubed. So I have to divide here. Okay. Now I'm going to rotate. So this is my y right here. That's my yi. This is the one I'm going to rotate about the y-axis. That's how I get my shell. Okay. So for a shell, I need the radius, the height, and the thickness. And finally, the volume. When I rotate, what's the radius? It's the distance from the axis of rotation to the shell itself, to this little piece. So from here to here, this is my radius. So my radius is the yi. My height is just the height of the shell. That's the height. So the height is the left value, sorry, the right value minus the left value. If this is yi, I need the value here. So I need the x for it. X is the cubic root of yi. It means in my mind, where I'm thinking, I know the yi. Right here is the cubic root of yi. So my height is going to be 1 minus the cubic root of yi. My thickness is the little delta y. Y is my variable, so the volume is 2 pi times the radius times the height times the thickness. So the total volume is the integral from, this is the interval I need to cut into pieces, from 0 to 1 of 2 pi, the radius, the height, the thickness. Questions before I move on?
Isn't the height the cubic root of y minus 0?
Think about it one more time. What should be the height? If you have the horizontal distance between 2 points, you always need the right value minus the left, or you get a negative answer. If I go back here, the right value is 1 minus the left value, which is the cubic root. I stop for a second so you can look at it. Oh, yeah. Okay. All right. Fine. So be careful. Be very careful when you're taking. Yes, it's right minus left. Think about it in your mind. If this is 1 and this is 3, what's the distance from here to here? 3 minus 1. That's really what it is. So it is right minus left, right minus left. No problem. My mind blocked today, so everybody has the right to have his blocked mind today, not tomorrow. So this takes care of 8. Now I will go through 15, 16, 18. 15. Okay. So what's 15 about? Okay. A sphere. So the idea is that you have a sphere, and a sphere is obtained, I'm telling you, by rotating a half circle of radius r about the x-axis. So this is how we get a sphere. We take a half circle. So this is r. This is minus r. And we rotate about the x-axis. And when we rotate this, we get a sphere. Okay. And my question is, find the surface area of the sphere. So I didn't give you much information. How do you think we're going to find the surface area? What do we need first? Quickly. So that's the formula for the surface area.
The radius.
It's R. So I want you to find the formula in general. I'm writing to give you a minute to think about it. If you want to use this formula to find the radius, exactly what we need is the equation of the circle. It means I need the function whose graph is the circle. That's what we need. R is fixed. R is fixed. So instead of telling you R is 3, 4, I tell you, okay, let's find it in general for any R. So step number 1, you need the function that whose graph is this half circle. Okay, so let us see what your classmate said. Equation of the circle is x squared plus y squared equal r squared. I need the x here. I'm sorry, I need the y. The y is going to be the square root of r squared minus x squared. Remember, r fixed. Don't be scared of r. R is just a number. So the function here is the positive square root of r squared minus x squared. So now what's the surface area? I have the f is the square root of r squared minus x squared. If I want to apply the formula, I need the f prime. What is the f prime? I need to find the derivative of this expression. Remember, r is a constant. Do not be afraid of it. So derivative is a half times a half minus 1 times the derivative of the inside. You forget the derivative of the inside, the problem will not be able to solve. 2 and 2 simplify each other out. This is minus x over basically the square root of that. Okay, so I can't find the surface area if I don't have a formula for the function. I either give you the formula or I give you a problem easy enough for you to figure out the formula. So the surface area now is going to be the integral from minus r to r of 2 pi, the square root, that's the function, times the square root of 1 plus the derivative square. Be careful, it has to be the derivative. And this is very similar to what I did yesterday and the day before in terms of algebra. One plus. Minus squared is plus, so it will leave me with x squared over r squared minus x squared dx. So finally, this would give me 2 pi integral from minus r to r of. I'll put them both under the same root and then I distribute. That's equal to 2 pi times the integral from minus r to r times 1. It gives me r squared minus x squared plus. I take this expression and I distribute. The denominator cancel each other out. I will have x squared. So finally, I will have 2 pi integral from minus r to r of plus x squared minus x squared cancel each other out. The square root of r squared is just r dx. Remember, r is a constant. Okay, we're deriving the general formula. R is a constant. I will have 2 pi r times the integral from minus r to r of dx. But antiderivative of dx is x. So this will give me 2 pi r x. evaluated between minus r and r, it means 2 pi r times r minus r plus r. So finally, I will get r plus r 2r, 4 pi r squared. Okay? So the idea here, we can find it. It's up to you to be able to figure out the function that we're working with. Okay, so let's take care of number 15. Then you guys are asking about 16, 18, and 27. Very good. Okay, let's look at number 16. Assuming a spring constant. So in number 16, it's the basic formula. Remember, for a spring, the force is given by a constant K times X, and the work, if you move it from A to B, is integral of the force. So number 16, I gave you the K. So it's just to give you a very basic problem here. And I ask you find the work required to A, stretch the spring 12 centimeter beyond equilibrium. Okay. Now to be able to do that, because our unit is meter, so this is my spring here, and I want to move it 12 centimeter. I have to do what you think at the beginning. To have unit coincide with each other, what do I need to do first? Convert. No. That will be hard. No. If you want the unit to be joule, you want everything to be in meter. So what's easier to convert now? Convert exactly 12 centimeter to meter. 12 centimeter is 0.12 meter. And now everything works. All right, so you have to convert the 12 centimeter to meter. You don't change this one. You don't change that one. Now, with this in mind, what's going to be the work? Is the integral from 0 to 0.12 of 800x dx. Okay, so the conversion has to be from centimeter to meter, not the other way around. So now this is easy. So it's 800 divided by 2 times x squared between 0 and 0.12, and you guys finish this up. All right? So the main thing in this problem is to make you aware that you have to convert to meter for the problem to work. So part B is the same, stretch from 5 centimeter to 15 centimeter. Again, I have to first convert, so 5 centimeter is 0.05 meter to 15 centimeter, it means 0.15 meter. So we divide by 100. So the work is going to be the integral from 0.05 to 0.15, 800x dx. And the rest is just computation. Okay. Question before I move on. So you convert to meter, and now whatever answer we got, that's joule. Because joule is unit of force, Newton, meter. That's what a joule is. So the force has to be in Newton, the distance has to be in meter. That's how you do that. How would you solve this without a calculator? Aaron, I had you last semester. Did you ever needed a calculator? No. Then you're not going to need them this semester either. I make up numbers, so things would work out. Don't worry about that. And in case you get stuck, I don't really care. Just keep it the way it is. Like in case that I say, okay, 0.15 square. You couldn't get it. It's okay with me. I don't really care about that. You got square root of 2, you keep square root of 2. I don't really care about that. That's why I asked you to show your work continuously. Thanks. So this take care of number 16. And now what you guys want? You got number 18 and 19 quickly. 18. Okay. I'm working when I see 50 Newton, for example. And what do I need to consider as... No. Good question. Newton is a unit of what? Force or work? Newton is a unit of work. So when you see Newton is a unit of force. It means when you see Newton, it is force, not work. Are you with me? When you see joule, it means you're talking about work. So let's look at number 18. What do they give us? If the work to required, so work to stretch is spraying 0.2 meter is 50 joule. Now they are giving us work, not force. The work is 50 joule. And the question is, find the work to stretch it an additional 0.5, and I explained it to you. Find work to stretch from 0.2 to 0.7. Okay, so the work is the integral. So what we want, that's what we want. From 0.2 to 0.7 of the force dx. And the force is k times x. So we have to find the k. Okay, and the problem should give us info if to find the k. So how I'm gonna find the k? All right, I have that here. What does this tells me? The work to stretch is 50 joule. This tells me that the work, which is the integral of kx dx, that's the work, is 50. This is equal to 50. Okay, and we're gonna find k using this. All right, so I solved for k. K is a constant times the integral from 0 of x dx equal to 50. So this is gonna give me k times a half x squared from 0 to 0.2. This is equal to 50. So it means k times x squared times 0.2 squared equal to 50. Now what's 0.2? 0.2 is 2/10. 2/10, it means it is 1/5. So this tells me k times 1 over 2 times 1/5 squared 25 is equal to 50. It means k is 5 times that 2,500. Okay, because I multiply, it's 50 times 50, which is 2,500. So the force is 2,500 x. Now I have a formula for the force. Now I can find anything. So the work to stretch from 0.2 to 0.7 is the integral. From 0.2 to 0.7 of 2,500 x dx. And now you find that answer. Okay? Now, before I take up in number 17, for example, in number 17, I told you a force of 50 Newton is required to keep spring stretched, whatever, by, how much I gave you? 0.1 meter. Okay, the force need. This is unit of force. So if I want to find a formula for the force in this problem, f of x equal k times x. And how does this read? This read that f at 0.1 equal 50. Now I'm setting the force equal to 50. And then you solve for k, which is going to give you 500. So in number 17, I gave you the force. That's Newton, which unit of force. You are able to find the k in this simple process. In number 18, I gave you the work. So you have to set the work equal to 50 and finish. Okay, so be very careful with the language that's used. All right, so what else do you guys have? Okay, number 18. Oh, we did number 18, number 19. Okay, number 19. Okay, the idea of number 19 is the following. So you have a very, very thin bar, very thin bar. So you have like some kind of a metal, and as I said in class, an easy way to think about it, you wrap a wire about it, but you wrap more and more and more and more. So the density is actually changing continuously. That's really the situation. So the density is not fixed, the density changing continuously. So we want to find the mass. The mass is the integral from A to B of the density dx. So if I know the density, if density is changing, to find the mass, I integrate the density. And I said the unit work very well. So suppose this is gram per whatever unit, gram per meter, and this is going to be meter. The whole thing will be gram, which so we're adding basically masses, so we're adding opposite mass. I'll do part A. I gave you a formula for the density. It's it's 150 e to the minus x over 3. And I told you that the bar is 3 meters. So that's 0, that's 3, that's my bar. And the density here is decreasing. So it's very heavy at the beginning. It's decrease, 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 decrease as we get close to the end. And the question is, what's the mass of that object? It's the integral from 0 to 3 of 150 e to the minus x over 3 dx. So it's really a problem of integrating the density. 150 is a constant integral of dx. And the only way to integrate this is substitution. Here, unit. I'm analyzing the limit. I'll put it here on the side. The unit of the density, as I said last time in class, is gram per unit of length per meter. Okay, so rho x dx. I'm analyzing this. Rho x, that's a density, a linear density. It means the mass per unit of length. That's what the density tells you. You multiply it by the dx. Delta x was these little pieces that we have to cut this. So this is a unit of length. The delta x is a meter. And then when you simplify this, you're basically ending up with a gram, which is a unit of mass. All right? Very good. So now we have to finalize this. Obviously, I need substitution. I have u is minus x to the 3. So I'm going to set u equal minus x over 3. The du is minus a third dx. It means the dx is going to be, because we know that's what we need, minus 3 du. And I just want to change the limit, right? Why not? Limit. If x is 0, my u is, if x is 0, my u is 0. If x is 3, my u is minus 3 over 3 minus 1. And now I will add upwards. So this is the 0 now. So it's 150 integral. The 0 stayed at 0. The 3 went to minus 1. This is e to the u. The dx is minus 3 du because I have x over 3. So finally, I will have minus 50 e to the u between 0 and minus 1. So it's minus 50 e to the minus 1, which is equal to, of course, you guys know that e to the minus 1, you keep it e to the minus 1. So, but this would give me 50 minus 50 over e. And the unit is going to be gram. That's in mass. That's in mass. Now, part B. What's part B? Part B is, I gave you the density as a piecewise defined function. It means the density is x squared between 0 and 2. So different part, and 6 minus x between 2 and 6. Okay. So this is my bar here. 0, 6, 2 right here. And different pieces have different densities. So here the density is increasing. So the density here is x squared. So the density is increasing here. And after that, a totally different formula. The density is changing but decreasing. So the density is getting less and less and less as we hit the end bar. The 150 is supposed to be 450. Am I goofing a lot? Yeah, you just added 4. Thank you very much. Okay, thanks. Yeah, you're right. It's 450. Okay. So let's go back here. So how are we going to find the mass? We have to find the mass of this piece, add the mass of that piece. So the mass of the first piece is the integral from 0 to 2 of the density, x squared, plus from 2 to 6 of the density, dx. And the rest is simple integration. Okay. All right. So the last thing you guys asked is 27 from the book. I will definitely talk. I know that I'm out of time, so 27. Okay. So 27 is verbatim what I did in 17 and 18. So 27 in the book, number 27, section 6.7. Okay. And the question is, calculate the work required to stretch the spring 0.5 meter from their equilibrium. So we have a spring. That's the equilibrium. We want to stretch it 0.5 meter. And they gave us, yes, Rocco, please do. Okay, because 27, I've already covered it. Make sure you take your ID for tomorrow. Make sure you have the ID. Make sure you have the ID. Okay? So the first question is, A, they gave us the force is 50. That's verbatim what I did a minute ago. So in this case, the force 50 to stretch 0.2 meter. So now we know that the force is K times X. They gave us the force to 50. It means in this case, you set 50 equal K times 0.2. Find K, then work. All right. In part B, they told us work is 50. If 50 joule to stretch 0.2. In this case, you're going to set the integral from 0 to 0.2 of kx dx equal to 50. Okay, so they're just contrasting to make sure you understand the difference between giving you the force versus giving you the work. Okay. All right, I'm personally done. Do you guys have any questions? Okay. I have office hours after that. What time am I to show? You told me 2 o'clock, right? Arthur? Come to my office hours. I think this is something that should be discussed in office hours. Join me in my office hours. Okay, any other question? All right, the best of luck for tomorrow, and hopefully I'll see you on Monday. Bye-bye, guys.